Hi everyone. Today I'm excited to share a project my team and I developed, an automated pet feeder with smart features. This innovative device is designed for busy pet owners who want to ensure their furry companions receive consistent meals even when they're not home. Let's delve into the technology behind this project. This pet feeder boasts a combination of hardware that allows for automated feeding and remote monitoring. The ESP32 microcontroller acts as the central processing unit, managing all the system's functions and scheduling. A servo motor precisely dispenses food portions based on your pre-programmed settings, or even through your smart home. We've also integrated a camera, allowing pet owners to check in on their furry friends remotely, adding a layer of peace of mind. Finally, a motion sensor that allows the camera to take these photos. Our primary focus in this project was on the core functionalities of the system. This involved ensuring seamless communication between the microcontroller and other components like the servo and sensors. I took the lead on the servo block, making sure that the motor operated smoothly and dispensed food portions reliably. This required delving into some C programming, a valuable skill for controlling hardware components like the servo. The ESP32 acts as the central nervous system, coordinating communication between all the subsystems in the pet feeder. It manages the flow of information from sensors and controls the motorized feeding mechanisms based on predefined feeding schedules and algorithms. The built-in Wi-Fi and Bluetooth capabilities open doors for future possibilities. The Mizui servo was chosen for precision and flexibility. It dispenses food accurately, like a tiny chef, for perfect portion control. Variable speeds ensures gentle handling of all food types. Overload protection keeps the motor safe, while Wi-Fi and Matter open doors to smart home integration. The result, consistent food dispensing, peace of mind for you, and a healthy pet. For the camera, we decided to utilize the ESP32 cam, which was designed to capture and send photos of the pets. This system aims to provide pet owners with visual reassurance that their pets have been properly fed when they are not home. The chosen camera system is equipped with its own microcontroller, which is distinct from the one in the main setup. The aim of this is to limit the amount of memory used on the main ESP32 microcontroller and have an additional microcontroller that will control the camera system and motion sensor. For the power supply, we use a buck converter to step down DC power. This ensures a reliable and consistent power source for the ESP32, camera, motion sensor, and motor, all while delivering the rated power requirements. To mitigate disruptions caused by power outages, a backup battery system has been incorporated, capable of sustaining power to the pet feeder for an extended 12-hour duration, which enhances the system's resilience and uninterrupted functionality. The power supply is crucial for the entire system because it will provide power for all of the devices responsible for feeding the owner's pet. The enclosure functions as a centralized input hub, integrating the core functionalities of the system. It houses various components including the motor, power sources, microcontroller, reserved food storage, and camera. Given the multitude of inputs, this central hub culminates in one singular point: the delivery of pet food as an environmental output, dispensed into the bowl at the specified time and in the predetermined quantity. Keep in mind, the process of food dispensing will be completed by the motor shown earlier in the presentation. For the motion sensor, we utilized an HC-SR501 motion sensor, which became a key component that added complexity to the camera system. The motion sensor serves as a key module for detecting motion and infrared rays emitted by the pet. This deliberate choice ensures that the system remains impervious to inanimate objects, as they lack the emission of natural infrared rays. By focusing on the presence of IR rays, the system becomes adept at discerning the living, breathing entity of a pet from other non-living elements. The code focuses on the design and implementation of the automatic pet feeder system's core code, executing on an ESP32 microcontroller. The microcontroller serves as the central processing unit of the system, handling critical tasks to ensure proper operation. Upon reaching a scheduled feeding event based on the time comparison, the code initiates a signal or action to activate the feeder mechanism. This activation involves sending a signal to control the servo motor that dispenses food. While technical skills are crucial, this project highlighted the importance of other qualities. We honed our project management skills by keeping each other on track and ensuring all tasks progressed within the set time frame. Effective communication and collaboration were also essential. We worked closely with each other, focusing on different aspects of the pet feeder's functionality. Finally, we documented the entire project clearly, ensuring future developers have a roadmap for further development and improvements. This project provided valuable insights for future endeavors. We discovered the ESP32 microcontroller's power and versatility as a platform for building internet-connected devices. We also learned the benefit of a modular design. By building the system with these components, we can easily add new features in the future, such as a pet identification through additional sensors. But most importantly, this project emphasized the importance of teamwork.